Hello, my name is Greg George from 3D Systems, and I'm a product specialist here. Today we're going to do a webinar talking about Geomagic Control. As many of you guys may know, Geomagic Control is a inspection software that we use for automated inspections. So today what I'm going to do is I'm going to actually scan a part here, talk a little bit about the scanning hardware, and then we'll move over to the software and I'll show how to run through an inspection process here live on the webinar. To start off, let's talk a little bit about what Geomagic Control is. If you guys can see my slide here, this is formerly Geomagic Qualify. It's a powerful metrology automation platform for the shop floor. And what we do with this is scan to CAD deviation analysis, GD&T callouts, geometric dimensioning and tolerancing, customizable reporting, including 3D PDFs, and it has a comprehensive automation possibilities. So we have a way to teach the software to repeat automation processes over and over again, and we even extend the software with a Python scripting platform as well. So you can write added scripts to extend the software. Just to talk a little bit about the scanning device that I'm going to be working with today. This is the Geomagic Capture device, and right here is the actual scanner itself. It's a blue light scanner. Just to give you an idea of the volume, if you guys can see the projection here on the table, you see that it's like a trapezoidal shape. Just to give you an idea of the dimensions here, this is a little bit skewed because of the perspective. But at the close distance here, the envelope is 124 millimeters by 120 millimeters high, and at the back it should be 192 by 175 with a depth of field of around 180 millimeters. You see that I do have a part here that we're going to be scanning as a real-life part, and I have targets on the part as well, and those are used for alignments. We have a variety of different ways to align the individual shots together. Today I'm just highlighting the target option, so the software will see those from the different perspectives, and then they'll flow into our software automatically aligned with each other. The scanner also comes with this tripod here, and then it also has a cable set up there with a Cat5 or Ethernet cable and then a power supply to go with it. And then, as I mentioned before, it does come with some stickers right out of the gate, and then you do have the ability to print your own if you need more of those. Okay, so again, on screen you can see that I have the specs here. I talked a little bit about the depth of field, and you see that it's about 1 million points per scan, and the accuracy is between 60 to 118 microns, and it comes pre-calibrated. So without going through any more PowerPoint slides, let's go ahead and go into the software and show the scanning process. The first thing that I do is I'm going to come over and go to the Capture tab within Geomagic Control, and then come over to the Scan icon. When I do that, you see that I have this window that pops up, and you can see this is a live feed, so if I grab the part and move it, you can see that it's updating on the screen. And I can go ahead and adjust a variety of different settings here. The default here is the exposure, and I can auto-expose the part, and just like with the digital camera, you can auto-expose the part and then you can compensate up and down. We do have HDR mode for certain parts that maybe have dark or shiny surfaces. You do have the ability to run HDR and high sensitivity mode, which is like a high ISO mode for a camera. And then if I go into the settings, you see that I have an auto alignment, and today I'm going to be using the target alignment, but I do have a best fit alignment that you can use as well, which will align to the last shot that you took based on the geometry that you scan. And then you can adjust the resolution. So today we're going to be running at high resolution, but you can set it for low, medium, and high. And that'll adjust how many points that it actually collects. So I'll go ahead and do my first scan. I'm just going to hit the scan button. And the first time I scan, you see at the bottom I have a status that tells me what it's doing, and it takes a couple seconds to connect the very first time. But you see there's our first scan. And if I rotate the part, you can see I can rotate to another orientation to fill in these shadows that I'm missing. If I hit scan again, it goes ahead and you'll see it populate over here the missing information from that first shot. So it's a line of sight, as we say. So if I go around the part, I got to make sure I see all the different areas on the part, and then I hit scan and it'll collect those. And while it's scanning, I can rotate the part around and look at the areas that I've missed and kind of plan out my next shot. You see here it says scanning, and then I'll say aligning, transferring, and then you'll see that that data pops up here. So the last highlighted pass is the one that highlights in green there. If I hit scan again, I'll just create a few shots describing some of the things on the screen. This is the plug-in to the software where I can actually add a prefix naming convention to the part. And then here it tells me how many points that I'm working with, so I can keep a track of how much data that I actually have. So if I go ahead and hit scan again there, can work my way around the part. I'll just take one more shot after this. Rotate the part and take one more shot. So that's the scanning process. Once I'm finished with scanning, once that final scan pass comes in, I just hit OK, and it takes me out of the plugin, and you can see that I can rotate the part around. And in Control, I do have the ability to edit the scan data here. So if I rotate it around, if I want to remove the table, I can select that table and just delete it and just crop that out. So you see I removed that table. So that's the scanning process. Before I move on to the next step, where we're going to actually create measurements between this scan data and the CAD model, we'll go ahead and take a quick poll, and that'll pop up here on your screen in a second. And from there you can vote. This one is what scanner are you currently using, and we have a variety of different scanners there. I'll just give you a couple seconds to go ahead and make your selection. All right, so I have my scan data here on screen. With Geomagic Control, the general idea of what we're trying to accomplish here is scan a real object and then compare that real object to the original CAD model that was designed before the manufacturing process, right? So what we're going to do is take the scan data from the real object and compare it to the CAD model. So if I turn on the CAD model that I imported, you can see here that's the gold object on screen, and I have that labeled as my reference object. And then you see that my scan data is not aligned with the CAD model. So you can infer the first thing that we're going to have to do is create an alignment between the two objects. And the way we're going to do that, if I come over to the Home tab, I can create a best fit alignment. And if I come into that command and just hit apply, best fit is going to automatically look at the geometry of the CAD model and the scan data and do a best fit between those two and create an alignment. Now I can use that as a basic alignment to start off with, and then I can create another alignment based off of that one if I want to. So if I really wanted to, we offer a couple other different types of alignments. Feature-based alignment, which would allow me to take different features on the part, whether it's planes, lines, points, and cylinders, align those together based on a datum reference frame. I can do those. RPS alignment is a reference point system. That's kind of like virtually setting the part inside of a point nest, similar to an automotive style alignment, where you have points and it's going to register the object based on those locations only. But for today, I'm just going to keep my best fit alignment, and we'll work from there. So you can see now that they're on top of each other. The first thing I'm going to do, if I have all of these measurements in 3D space aligned to the CAD object, one of the most popular things to do is just to create a 3D comparison between the CAD model and those points. So what a 3D comparison is going to do is calculate the deviation of each one of those points to the CAD model, and then graph that based on its color value. And then I can rescale the color spectrum to show me a graphic display of the deviation between the real-life part and the CAD model. So you can see it calculating right now. It just takes a second to calculate, and then it'll pop up with this color map on screen. Right now I have it set for continuous color spectrum, so you see here how it's like gradient from green to blue and yellow. I do have the ability to switch over to continuous. I can switch it over to continuous, or I can switch it over to a spectrum based on the divisions. So you see here I made the hard breaks between the color spectrum. Sometimes that's easier to visualize the areas of deviation. I can also rescale the color spectrum. So if I wanted to set my max and min at 2 millimeter and hit apply, you can see that it rescales the color. If I hit 0.2, it rescales it as well. So I'm going to go ahead and leave it with this method of color. And you see that based on the deviation, I can look at the part and figure out that this dark blue area is negative 1.2 or negative 2, and I can get an idea of the deviation. But if I need to make hard measurements on these different locations, I can come in and I can create annotations on the surface of the part. So if I come into the annotation tool and click on the surface of the CAD model, what it does is it makes a spot measurement right in that area, comparing those points with the CAD model, and it gives me the deviation in 3D, X, Y, and Z respectively. So I can come around the part and click on those areas in question and get real-time feedback of what the deviation is in that area. So you see here I created a bunch of different annotations, and if I look at the bottom, I have those labeled, and I have a spreadsheet of the deviations that's going to end up inside of my report at the end. One thing that I can do is I can create a saved view. So if I rotate the part around, I can hit save, and it'll save that perspective with those annotations. And if I want to create a new view, kind of like a drawing sheet, it'll create a new view, and I can zoom into another area and pull out annotations as well in that area, and then save that area as another view. And just to show that these are two independent views, I can toggle back and forth between them. If I go annotation view 1, it'll zoom out to the area that I was focused on before, and if I do annotation view 2, it'll take me to that area that I was working on with the second area. So if I hit OK, I've created some annotations based on that 3D comparison. Another type of analysis that we can do is a 2D comparison. I can change the view and then the orientation of that plane as it intersects through the part. And then I can go ahead and compute a 2D comparison. And then I can adjust. This is basically a whisker plot. And I can adjust how many whiskers I can see on screen. So if I hit 500 here, I'll recalculate with 500 whiskers. And I can rescale them as well. So if I type in 10, you see here that I extended the whiskers out, just exaggerating the deviation. If I hit 5, you see that. And what that does, if I zoom in, is it shows me a 2D comparison of the actual CAD model, which is in red, and then the black measurement points, which is the scan data that we collected. And then it shows me the direction of the deviation there. If I want to annotate that, I can get out of this tool and come over to my 2D comparison and then hit the annotations and do the same thing that I did in 3D compare, except for with the 2D compare. And then the view format works the same as well. So if I come in and drag out these comparison points, I can save views. And if I say new view, I can come into a certain location and only pull annotations in that area as well. And then hit save. And again, just like before, the table is prepared below, and that's going to end up inside of the report. So far we did a 3D comparison and 2D comparison, and we created annotations on those parts. Another thing that we can do is I can come into the CAD model and create some features on the CAD model. I did before the webinar, I went and just created a couple features on the surface, and I labeled them as datums. So I have datum A, B, C, and D, some planes and a cylinder. You can see over here on the left-hand side. One tool that's really neat with control is the ability to create those same datums that I have on the CAD model over on the actual scan data. So if I use the Auto Create tool, it'll automatically take those same features that I fit to the CAD model and move them over to the scan data. And the reason why I'd want to do that is on the CAD model I have those perfect datums in space, and I may have to select that geometry and fit a plane to the top of the flange here in order to fit a imperfect plane, so I can measure the deviation maybe of the direction normal of that plane. So if I hit OK, you see these orange ones are actually on the scan data itself. So what that Auto Create tool did is it automatically created selections of the top surface and the side surface and the areas that made up those features, and then fit automatically the planes and cylinder for me on the scan data. And what that does is it allows me to compare them to each other between the test object and the CAD model. So if I come over to compare features, I can take this test object and click on that top plane and compare that top plane on the CAD model to the top plane on the scan data. And you see here I get a form value and the deviation X, Y, and Z. Now if I want to change what it displays for this plane, I can change the normal direction, and I can say I want to show the normal deviation between the plane on the point cloud and the plane on the CAD model, and it updates my annotation. And then just like before, I can save the views and I have my table. If I want to adjust what else I'm annotating, I can come over to Filter Features and I can say, maybe I want to show the cylinder and pull out a comparison on the two cylinders. It gives me the form value, and then just like before, I can adjust what it shows. So if I want to show the the diameter, the reference diameter, the test diameter, and the deviation. You see, that's what I'm showing. If I want to add the direction of deviation as well, I can just add the 3D direction deviation and hit OK, and that'll update my annotation. And then just like before, I'm going to save that view in order to create a report later. So if I hit apply, we went ahead and created some compare features. Another thing that's nice to be able to do is create GD&T callouts. If I come over to the GD&T tool, let's just say I want to compute a flatness callout on this top surface, and I can type in my nominal. So I'm going to type in 0.2 and hit next and OK. And if I come over to evaluate GD&T callouts, I can hit apply, and what it'll do is go take all those points that make up the plane of the top surface, and then create a flatness callout for me, and even give me the actual numbers. If I come over to color detail, it'll even give me a color scale to give me an idea of how close it is. If I hit OK, so I created a GD&T callout. Another thing that is extremely valuable is the ability to come over and cut a cross-section through the part. And you can see here I can just slice it in a variety of different ways. And then I can compute that cross-section and make measurements on it. So if I go ahead and I'm just going to hit next and OK, come over to 2D dimensions, I can make measurements based on that cross-section. So if I come in and grab this horizontal tool, and then I can change the data that it looks at. So if I change it to pincers outer, what that does is it simulates the ability to wrap basically virtual calipers around the outside of this part. So if I window in this area and this area, you'll see that it makes a measurement based on the high point. And you see I have an outlier out here, so it measures based on the highest point, just like a pair of calipers would be. And I can do the same thing on the inside as well. So if I come in and say pincers inner, I can window in this data, and pull a measurement on the inside. Not only can I make measurements on the scan data, but I can actually make measurements between the scan data itself and the CAD model. So if I window in, I can come in and say, maybe I want to make an angular measurement between the CAD model and the test data, and pull out an angle measurement. So you see here that that was a 1.8 degree change there. So the actual part is drafted, but the CAD model is not, and we're able to measure the deviation there and the angle. And just like before, I'm able to zoom in and create views and save those views. Just to highlight a couple other things before I exit this tool, I do have the ability to measure from features, those features that I created. You see that the planes that intersect and the cylinder that intersects this part. And I do have the ability to create constructed entities too, like lines, points, and things like that, and measure between those and the data itself. So that is 2D cross-section. And the last area I wanted to show is the ability to create measurements in 3D space using the 3D dimensioning tool. So if I come in here, I can make a measurement. Let's say I want to make an angle measurement between this plane here on the side and this plane on the top. So if I say I want to make a 3D measurement, and then I want to go ahead and take and make an angular measurement. So I'll come in and make an angle measurement between that top plane and the side plane. So I'll go ahead and select angle. I'll turn off the plane there. Select that plane, and pull out a measurement. Now right now we're making a measurement between the two planes on the CAD model. So what I'm doing here is I'm going to go ahead and make that plane measurement on the CAD model first, and then we'll go ahead and automatically create that same measurement over on the test data. So if I hit apply, you'll see here that it says OK, and I can come over to the test data and turn on my dimension view, and you see here that it measured that as 90.8090 between those two planes. So we created a 3D comparison, annotations, compared some features, GD&T callouts, and some dimensions in a cross-section. Now the next step is to go ahead and create a report with all those measurements that we created. So I'm going to go ahead and come over to my Reports tab, and you see here that I have PDF selected and 3D models selected. So I'm going to go ahead and hit Create Report, and it'll take everything that I just measured and dump that into a report. And the first page will actually have a 3D model on it with the 3D compare in it. So that way you can, when you send it to somebody, they can actually get a visualization of the model itself and all the results from the inspection process. So while this is calculating before it shows up, I'll highlight there are two other things that actually make this software really powerful. One of them is the fact that everything that I did, it created an automation process for me automatically as I made those measurements. So all the measurements that I made, the software recorded those and can repeat those over and over again on another part. So if we scanned another one of these flanges, all I would have to do is hit run, and it would create the inspection report automatically for me. We refer to that as the automation tool inside of Control. But we also have another way to stack even more functionality on top of that. Let's say that I scanned already 50 of these parts. We also have the ability in here to create a batch process where we run the same inspection routine on a batch of parts all at once. So what it'll allow me to do is batch process all 20 of those and spit out 20 different reports of the entire manufactured lot that we have. So I'll highlight that here again in a second, but before I do that, let me just point out that on screen I have this PDF that's basically just opened in Adobe Acrobat. Now if I click on that first page, it takes it a second to load. You see my cursor loading the model. And then once it finishes loading, I can rotate the part around here on screen and look at the deviation. So this is nice because somebody doesn't need extra software just to get an idea of what's wrong with the part. You're able to send it to a manager or somebody else that maybe doesn't have the software, and they can look at the part and visualize what may be wrong with it. Just to highlight a couple of things in the report, if I zoom out, it gives me my alignment statistics based on that best fit alignment that I did. It gives me the 3D comparison results, and you see it tells me where my deviation falls in this bar chart in the different categories. And then you see that annotation view with the perspective on the part that we captured and the measurements that follow with that. And then that view that we added too, where we zoomed in and created a couple measurements in that other area. And you can see there, here's my 2D compare with my annotations there. And then I do have the 2D, that second view for the 2D comparison. And you see my 2D dimensioning view with the dimensions and the table that goes with it. And then you see I have my my measurement that I did between the two planes, and then my compare features as well in this report. So that's the 3D PDF report. Before I jump to the question and answer time, I will just show you that automation tool that I referenced. But before I do that, let's take another poll question, and I'll give you a second to answer the poll question before we move on to this last section. All right, so now that you can see my screen again, this is the automation tool that I referenced. Everything that we did were we created features, we did a best fit alignment, 3D comparison, all the way down through creating a report is all recorded here with all of our settings. And it learned that as I created those measurements. So all I have to do if I want to run this inspection again is scan another part, come over to this automation tool, just right-click on it, and then hit run, and it'll run that same exact routine on the next part. And also, as I hinted at before, that batch processing tool here, I can point it to a folder full of parts, tell it which automation that I want to run, how I want to save the files, if I want to save them, and then where to output my reports. So I don't even have to be here in order to run this. I could actually set this to run automatically and process all those parts. And at the beginning I referenced the ability to script. We do have a scripting tab in here where you can load and create your own Python scripts, extending the ability of the software to create measurements in a variety of different ways. We have a lot of customers that have written their own full-blown applications to integrate Geomagic control into their measurement process. So there are times where people don't even realize that control is making those measurements because the script is running automatically in the background and pulling the information straight from control and flowing it into another resource that you have available. So that is the scripting tab that I wanted to recognize and point out, because that really extends the power of Geomagic control. All right, so now that's the end of my live demonstration. What I'd like to do now is take questions, and I'll go ahead and turn on my video camera here so you guys can see me, and we'll actually take some questions if you guys have any based on the scanner or the software today.
Great, thanks, Greg. Folks, right as he's getting the camera back on, and we're going to kind of organize a few of these questions, I've got one more poll to ask you to fill in, and we do appreciate the responses, so please fill that out, and then we'll get straight to the questions. Great. So we got Greg back on. He's also got a screen. So Greg, we have a handful of questions in here. One I'd like to ask you very quickly is the 3D PDF file that you created today. Do you have a version you'll be able to save out for us that we could provide to the attendees to download and look at when they get the reminder, the follow-up email with the link to the webinar video and everything else?
Yeah, I can actually save that PDF report out.
Great.
And we'll upload that to the follow-up email that you guys get with a link that you can download it and look at the measurements and stuff.
Great. So while we're on the topic of that, of the 3D PDF report, there are a couple questions that kind of correlate to that. So let's go to one of the first ones here. Here it is. The 3D PDF report with the color map was very nice. Do I have a choice to specify that picture as only a 2D picture instead of a 3D rotational view? If so, what is the file size difference between these two options?
Okay, we do have the ability to change that cover model to being a screenshot of an image if you want that to swap out with the model. And yeah, that will reduce the file size. What we're doing in the background is reducing the model down to a manageable size and putting that preview on there. So what I would say is maybe a regular report with images only, maybe less than a megabyte or floating around there somewhere. And then if you create a 3D PDF, many times it could be up to 10 megabytes or less. It just depends on the model that you're dealing with. But that's generally around where they float, 10 megabytes or less.
How flexible are the formatting on the reports, including resizing tables and graphics?
So we do have the ability to, if you guys can see my screen, you do have the ability to create report definitions and style templates. So we do have a style template designer that will open up the style and actually has all the XML attributes that you want to adjust, along with fonts and tables and things like that to adjust. And then the report definition actually changes what gets reported, so what the software is going to hand off to the style template. So you can customize both of those and save your own templates on screen here. So you can see that I actually have my own report definition right now that I'm running. It's called Greg. And then the style template is just the default letter portrait. But you can edit anything about it inside of the report editor. It looks kind of like Word with XML attributes that you can change.
Awesome. Are the images on the reports based on vector graphics, and can they be scalable?
They're not based on vector graphics. They're actually raster images that are screenshot from the software. You can adjust how high quality those are, but they're actually just screen grabs from the perspective that we were looking at when we took the measurements and hit save when we were in those views. So they're raster images.
There was a question here that I'll answer very quickly for everyone. What is a ballpark number for this scanner cost? So this solution, the Geomagic Capture for Control solution, is listed at $24,900, which is excluding the mandatory first-year maintenance. And Geomagic resellers and also our own RSM teams can fill you in a little bit more about what those details are. So thank you for that question. There's also another question. Is there a turntable available with the scanner? Currently, no. We are looking at potential accessory turntables. However, our resellers and also our RSMs could recommend a suitable turntable for these devices. And another one. This is going to be one for you and I, and then we can move on to some of the more technical questions. There was a question in here about, and sorry, they're coming in so fast. Thank you all. Let me find the one I was looking for. Sorry, everybody. Here it is. Is this scanner akin to a Kinect Xbox? Is it used for anything in the arts such as jewelry? So the first part of the answer is this is not akin to a Kinect Xbox because the scanning functionality is much different. However, I think Greg can give you a little more detail about how this, in conjunction with other products we offer, might be able to help with arts such as jewelry and scanning of that size. So do you want to give them just a quick, here's an option that we would have?
Yeah. So this isn't the same technology. This is called blue light technology, so it is a little bit different than our Kinect-based technology, which is called the Sense. This one, based on the envelope, may not be the best for jewelry because, as I was saying before, we have like 124 millimeter wide by 120 high at its closest point. So based on the million points that we have to work with, not many of them would hit a piece of jewelry if you were scanning that. There are some other solutions out there that are very good for jewelry that we could that we could recommend based on our account managers in their different regions. If you want to be contacted, we can suggest you some different devices out there that may be good for that type of application.
Question, currently running Qualify 2013. Can I update to Control 2014? So the answer to that is yes. If you're on maintenance, you would be able to update to Control 2014. The caveat here, and what's important to know, is that Geomagic Capture for Control is a different system. So updating to Control 2014 would not include the capture system. That's a separate cost altogether. And again, a conversation that any of our RSMs or resellers could help you with. Let's talk a little bit about some of this. We got some technical questions here. Actually, there's a few just related to GOM. So we use a GOM system right now. How is your accuracy if we're measuring on SLM metal parts?
This device is, especially based on its price point, is between the 60 to 112 micron accuracy. I know GOM has a wide range as well of accuracies, and some of them are very, very accurate, and some of them are a little more loose. But at the 24,000 with software only, this is it's a pretty good solution as long as you can fit it within that accuracy range, of being 60 micron. So that's how I would compare it. It's not necessarily a GOM or a GOM type of device, but it's also in a totally different price range, at a different price point in accuracy. Now, it does pretty good with the different surface finishes, but it'll have the same limitations as GOM does as well with blue light and white light technology. Now, we overcome some of those with processing in like the HDR mode that I highlighted before, but there are those maybe certain colors or extremely shiny objects that it's going to have issues with, and that's just nature of the physics problem that we're overcoming with the type of technology we're using, and it's going to be inherent in both devices.
Okay, and while we're on the subject of GOM, I currently use GOM Inspect, the surface profile algorithm. Let's try that one again, huh? The surface profile algorithm is based on ISO definition, which is different from ASME. Is your surface profile algorithm based on ISO or ASME?
Ours is ASME. So I do not believe we could double check that to see if it's on the ISO, but right now I'm pretty sure that we're still ASME only certification on Control.
Okay. So I want to talk a little bit about size here. There's a lot of questions in terms of relative size. So maybe can you just give a brief kind of overview of the size, spec, dimensioning that you're looking at? You can see the blue light on the table. We can all see that, but can you kind of give a little bit more of an idea of what we're looking at working surface-wise?
Yeah. So as I was saying before, the width is the 124 at its closest point by 120 high that you're dealing with. And this perspective is a little bit skewed, but it is a trapezoid shape to the volume. And then it's 180 millimeters deep, its focal range. So you have basically this 3D trapezoid that starts out at 124 by 120 and then ends up at 192 by 175 at its largest point, because its camera lens is looking out, right? So that's why it is that shape. So that's the volume. And, for inspection, ideally you would want your whole part to remain inside of that volume. But you could go outside of the volume with some targets to scan a larger object. It would just be less automated to scan those parts than it would be to have the part fitting entirely inside of the volume the whole time.
Folks, there's some people asking questions in regards to some of the design packages that we offer. Geomagic, so mentioned before, Geomagic Capture for Control. Geomagic Capture for SolidWorks, Geomagic Capture for Design X. If you go to our website, geomagic.com, and go to the Capture page, you can go to the Scan-Based Design section, fill out a free trial request, and one of our RSMs will come back and provide pricing. Some things can kind of vary depending on what you're looking for, and it's usually easier to just have that conversation one-on-one with them. For today, we were able to give an exact pricing because based off the system that we're showcasing inside of here. Let me see. Sorry about this. So there are a couple of people who've asked about big stuff. Okay, one guy is asking, we make a large part that's approximately 8 feet by 9 feet. Does the scanner need to work in cooperation with photogrammetry software to analyze more surface area? Can it be moved through it step by step, or is that just simply too big?
It's possible, but it is big to do it in an easy fashion. I mean, you can put the stickers all over the part, but right now we don't support a separate photogrammetry feature where we could take a large overall shot of the targets and then take individual shots of the part. So what you would have to do, the technique that we're using now, is put the stickers on, and they would have to be overlapping shots that include at least 3 of the stickers, if not more, and to increase accuracy. Overlapping shots to go all the way around. So you could imagine if you got at your biggest envelope 192 by 175 on a 9-foot part, that would take a while. And since this is a fixed envelope right now, we don't have any way of scanning larger areas unless we just leapfrog around a larger object.
And then again, another guy has a question: what about a keyboard? What if it, constant like a keyboard? Could you just pass it through multiple sections to get the full scan on something like that?
Absolutely, that would actually be fine. Especially, and you got to remember too that you don't have to have the targets on the part too. You could actually set the keyboard on a table that has targets all around it, and as you scan, it adds the targets to the current overall target coordinate system in a way. And so you could set that keyboard-sized object on a table with the targets already on it and work your way around it. And really, that size is only 2 volumes big, so you would be able to still get very good accuracy, I think, between all the scans.
A couple people have asked us now too, for inspection, which software is better, Verify or Control? So folks, the answer there is it's fairly simple. When you're looking at Verify, if you're looking to use Geomagic Verify, you're looking at first article based inspections. For Control, like you saw today, it's more based around automation and the ability to go in, write your own scripts and codes as well to tailor it to exactly the kind of inspection process you have. So you have different different channels depending on what's best for your business model. Can we talk a little bit about light? What's the best light conditions? Can this be used outdoors? Is it strictly an indoor device? That sort of thing.
Yeah, it can be used outdoors, although there's going to be some light that's within the spectrum of what the sensors are going to be looking for. So ideally, you try to reduce the amount of light that can throw off the measurements of the part. But if you were outside, I would definitely try to put a shade of some sort over it. It just helps increase your measurement accuracy. As far as indoors, we measure all the time with the regular incandescent or fluorescent bulbs, and it's perfectly fine. But yeah, as far as the device itself, it can be outside. It's just I would definitely shade it because the colors can wash out. If you think about it with the same idea as photography, you got really bright light that's competing with the blue light that you're emitting and trying to receive back, right? So I would try to avoid that. It is possible, but I would definitely avoid it.
Is there any specific features like color texture capture?
Oh, color texture capture, we do not have that ability right now. What this is basically only 3D measurements. It's on the list of considerations to take into account for maybe future devices. Color is with the prominence of our color 3D printers and a lot of different other ways of producing color. It's become a hot topic of having scanners that you could collect color with as well. But you can also, by the way, if you have another method of collecting color texture, you can apply it to these models that we collect later if you want. That's an option that we do sometimes.
Trying to find you a couple good ones to get a little skip out of that range. Can you please explain, when you have a moment, on how the scanner is connected RJ45 via network? Can you just once again walk through how's that scanner connect through?
Yeah. So it has a Cat5. There's a custom connector here actually on the scanner. And inside of this cord there is the power and Ethernet. And we're running with a static IP set up right now to the Ethernet card. And then we have an automatic feature that will help, it'll actually change you over. So if I come over to settings here, I have this auto connect tool. And what we do when you hit auto connect inside of the plugin is go to your Ethernet adapter and change it to a static IP and set it so then we have this network connection between the device. There are a couple people that have had success running the USB to Ethernet adapter, but it's not fully supported. If you try one and it works, then that's great. It's a nice option to have. But if you have other network connections, honestly what I do is I use the USB to Ethernet for my other devices such as internet and things that are simple, and then use the Ethernet cable for my scanner, and then that way it solves the problem of having one Ethernet port.
Geomagic Control by itself, just for a moment, will this software work with a Faro V2 laser scanner?
Yeah, it works with the V2, which would probably be on a platinum arm, right? So you could run connected to the arm and then just go switch over the device that you want to use and scan with the capture and switch over depending on which device you want to use for your inspection process.
And also, can Control run GOM scanners?
You can't run GOM scanners. They have proprietary software that actually runs and processes their data. But we do often with Control work with GOM data quite a bit. So you can automate GOM to scan the part and spit out the file, and then we can grab the file in an automated fashion and process it as well. We have a bunch of customers that actually do that. So they take the data straight from the GOM into our software, and we can even automate that in a batch process if you want to as well.
So a couple questions about surfaces. We all know what the first one is the popular, can this do shiny surfaces? And then beyond that, there was also a question about red surfaces. So can you go maybe just address those two and then just cover surfaces in general?
Yeah, so it does have the same drawbacks as any white or blue light type of device. So shiny and colors sometimes have issues, and I actually have had a lot of success so far with the different surface finishes, especially with the option to run HDR mode, which essentially takes a bracketed shot. It'll take shots at different exposures and still be able to collect some data that's accurate. Now, as far as the colors, from what I've heard people say, red and sometimes orange have issues with the blue light. But so far I haven't run into that many issues, especially if I'm running with the HDR mode. Obviously, if I do just a single exposure, the same blue light problems are going to happen no matter what device that you have. But if you can switch over to the HDR mode, it actually gets pretty good data, and I've had some good success. Honestly, the best way is to have your regional manager from 3D Systems maybe scan a sample part. That's the only way for us to really get a good idea of how well it scans that exact surface finish and provide you with the sample and see if it meets your expectations.
So, good question here. Kind of ties together a little bit about the 3D Systems culture itself. If we build a part in a 3D printer, and then measure the part, would it be possible to create a new CAD file that are corrected? So building number 2, we will build with a change CAD file from Geomagic Control that is changed optimally for better accuracy.
It is possible, but you would need a separate piece of software. So Control is going to collect the scan data and make measurements, and that is what its purpose is. But if you wanted to then take that same scan data that you collected and make changes to it, you would need one of our other softwares, such as DesignX or DesignDirect, to make the changes to that would then be corrections to then print again or manufacture the part. So this one only revolves around measurement, and then we have other software packages that revolve around scan-based design that could actually change the design itself to make it result in a good part.
Is there a way to create an inspection plan of a model without the part to use once a part is available? Can report show pass-fail?
So we can actually create ahead of time the inspection routine. It is important to point out that you would need the CAD model, and then from there you can set up basic routine. And often what I will do is actually just take the CAD model itself and convert it over to a sample scan data set, just a fake piece of data, to then create the whole routine accurately. And then when I do that, I can throw away that sample scan data set, and then go ahead and bring in the real data once I have the throughput.
Is the accuracy value only for one image, or is it the accuracy after registration?
That actually is for an individual image. So registration is an unknown. It just depends on the execution of the scans, how much overlap there is. There are a few different factors. But often what I will say to people is, if you execute a scan properly, it is possible to get alignments that are within the same tolerance as the device itself, providing that you scan properly. So with our best fitting and our algorithms that we're using to process and merge and align the data, it almost always falls into a better category than the device itself when we're merging the data itself. But if you don't have overlap, then it makes it very difficult, and then that's where your accuracies on overlap and between the different shots deteriorate significantly.
Okay. So, folks, we're kind of coming to the end of the webinar here. There are a lot of questions. I wanna touch on one that's kind of not as redundant as some of the others have been, which is can dental models be scanned in this process?
Yeah, I believe that a lot of the dental models, as long as you're talking about like impressions, are about this size. So you can get very good data, especially if you keep it closer to the front of the envelope. You can get excellent data. I would definitely try a sample and see if the local regional manager can scan your impression and see. Now, if you're talking about scanning actual industrial parts that pertain to dental, like brackets and brace pieces, the different pieces like that, those are going to be very, very small, so that's going to be out of the realm of this. But if you're talking about impressions, I think this could probably do it. But I would definitely like a chance to try it and see how well it works.
So, and then there was a follow-up to that very quickly is, well, can you do the direct scan in a mouth? Which I think is probably a little more challenging given the interface of the scanner, but again, I guess maybe it depends on how you mount it, or I don't know. What do you think?
I don't think it would work that well. I mean, in theory, you might be able to get a couple shots, but it's not going to get enough information, I don't think, to accomplish what you're probably after. There are a lot of intraoral or chair-side scanners now that are starting to pop up that do a really good job with that. So you would probably end up having to go that route. The Where I think this could actually do it is the impression side that I mentioned before. If you scan the impressions, I think it could do it. But I don't think that share side, it would be able to do it.
So we're kind of at the end of the webinar here. So folks, there's a lot of questions in here that probably could be answered at geomagic.com. If you go to geomagic.com, click on the Geomagic Capture option in products. You should be able to find some more information, things detailing resolution, other things, dimensions of the device, as well as some of the different plugins, not just for control, but for verify and some of our design offers as well. For the other questions we didn't get answered to, we're going to be sharing these around with our teams, and we'll make sure that people get back to you as soon as possible to get the answers that you need. We appreciate the time attending our webinar today, and especially answering our polls. Thank you, Greg George, for an excellent demo, as always. And there will be a follow-up email sent to this webinar that will have a link to a landing page that will have this on streaming, as well as some additional information on the product. So thanks again, and have a wonderful day.
All right, thanks a lot.
Whew.